Java implementation of a 8puzzle solution. My solution has three classes, three files, which is heuristics, puzzle, and strategies, and the main file is the puzzle one. So it has the main class, which is puzzle, where you set all initial parameters to run the program. So when you run the program, you select the mode, which is easy, medium, hard, and then you select strategy, which is basically an algorithm. And also what you do is you set the heuristics object, and this heuristics object is basically a constructor where depends on what sort of heuristics you select, it will calculate the estimated distance to that. So when you select for instance, the misplaced tile one, it will show all of the statistics for that. It will also show all of the path it took to that solution, and different costs and heuristic estimations all on the path. Besides that, there is a node implementation, which is basically the a class which represents a node in the search space. It has the successor parameter, which is basically all of the nodes, all of the possible nodes, all of the possible moves that tile can make on a board. Also the parent state and the tile list. The tile list is represented as a one-dimensional array, and represents all of the tiles in the board. Also the cost of current state, heuristics of the current state, and total cost of the path so far. So the main successor method is basically the expand method, and it will find the tile in a one-dimensional array, and then it will try to make the move. Basically it tries all of the moves, and for each of the move it will get the index of possible move and also the constraint. If it passes the constraint, it will create the possible next node where it will set the cost, which is the basically the value of the tile. The strategies file is all of the implementation of the BFS, DFS, and the cost search. I decided to make it separate because to make it more readable. So for BFS, I'm using a queue implementation. Also, I'm using hash set in all of the solutions to check for all of the visited configurations of the node. So basically how it works, it's trying to expand to check for all of the possible configurations of the node, and we'll check if this configuration was already visited. And then it will add to the queue this successor to the queue if it wasn't visited, and then it will take the next node from the queue and try it again until it finds the solution. The DFS works similarly, but I'm also adding the iterative parameter to check for the deep iterative to make the deep iterative solution. Deepening solution. Here it uses the stack and also the hash set. So it will do the same. Basically, will check. It will get the next node from the stack, and also check for all the possible moves. If this configuration was not visited, it will check if it is iterative deepening solution. And if it is iterative deepening, it will check for the current depth. And then we'll check for all of the, it will add this successor to the stack, and we'll continue to do that until all of those nodes will be visited. So if all of the nodes were visited, then it will get the next node from the stack and check if this goal was found. The cost search solution is basically the main method is the main implementation for the best first search, uniform cost, and A-star solutions. And I'm basically adding the heuristic type, passing the heuristic type parameter here It works almost the same as the previous one, except I'm adding the priority queue implementation here, which serves as a min heap. And the way I'm doing this is I'm using the comparator function, which basically works as the min heap. So when it expands the node and checks for all the possible solutions, I'm checking for heuristics, and if it is a best first search, I'm just adding the heuristic cost, and if it is something different, then I'm checking the whole cost, and successor cost, and also heuristic cost, and add the successor to the min heap, and then after that we'll remove this the minimum solution